Okay, so adding and subtracting rational functions. Really pretty easy stuff, guys, because we know how to combine like terms. Like x plus x is 2x's, right? X plus 3x's is 4x's. It's the same idea. So to be able to add radicals, you have to have like radicals. Now it's pickier than with multiplication. So with multiplication, remember from last time, like square root of x times square root of y, that can be written as a square root of xy. Even though underneath is different, we can put them both under the same square root, right? But that is not true with addition and subtraction. So for them to be like radicals with addition and subtraction, the root has to be the same, and what's under the root has to be the exact same, or else they're not like terms and you can't put them together. So if they are the same, then you just combine them like terms. So look, 4 apples plus 5 apples is how many apples? 9 apples. So 9 root x's. Does everybody see how it works? They're just like terms. 4 root x's plus 5 root x's is 9 root x's. It doesn't change the apple, I say. So right here, 4 root x's minus 5 root x's is how many root x's? Negative 1 root x's. I always have somebody get this weird mindset of like the root x's subtract away. That's not true. Like, right? 4x minus 5x isn't just 1, right? The x's didn't go away, right? It's just negative 1x. Does everybody get what I'm saying? Or what people do on accident? They'll like say the radical went away because we'll just subtract it off, but that doesn't make sense. They're like terms. Okay, so let's do this one. It's pretty easy. You might even need to take notes for some of these. 4 cube roots of 4 cube roots of x minus 4 plus 10 cube roots of x minus 4. Can we combine them? Yeah, they're cube roots of x minus 4. The apple part is this. The apple doesn't change. So how many apples? 14 cube roots of x minus 4. So that's simple. So 9. We can combine these. I think we get the picture here. Let's do one with 3. So 3 cube roots of 10 minus 7 cube roots of 10 plus 2 cube roots of 10. So it looks like that's 3 minus 7, which is negative 4, right? Negative 4 plus 2 is negative 2 cube roots of 10. Just combining like terms. Now here's the thing, here's the catch. Okay, so this is the one time now that we start to get a catch. So if you look at this right here, right now, you might say that we can't add them because the apple's not the same. Here's the thing though, we always have to check to see if any of our radicals can simplify. You have to have radicals in the most simplified form to know if they truly can be added or not. Because they might be like radicals in disguise, meaning they actually might be like radicals if we simplify them. So look, this simplifies, that would be 5 times 4, 2 times 2, so when we pull out a 2. Now watch what's already on the outside, you'll multiply it to that. So now we have this, 6x root 5 was left and x was left. So 6x root 5x. Then we have right here, it looks like x cubed is x times x times x. So we'll pull out an x, won't we? So then we have minus 5, now we have times x, square roots of 5x. So now look. Here's the thing, guys. These are the same. Look, root 5x, right? But now there's another element involved. There's an x in front. They have to both have an x. So this is actually, the apple part's this. X root 5x. X root 5x. There's the apple. Does everybody see? So if this one didn't have an x, they wouldn't be the same because this would be 6x root 5x, and this would just be root 5x if this wasn't here. But it is, so we're good. 6 minus 5 is 1. So we have 1x root 5x. Does that kind of make sense? Okay. So that's just the new element. Is make sure all your radicals are completely simplified. So same thing here. If you want to just watch, you can because they're really pretty basic. 9 times 2, 3 times 3. So we're going to have a 12 root 2. Then this breaks down into 2 times 2 times 2. So we'll pull out a 2. So then it would be minus 6 root 2. So they are the same. 12 minus 6 is 6 root 2. So once again, same idea here. We're going to simplify it. 54 breaks down into 9 times 5. Uh-oh. It's not 9 times 5. That's 45, isn't it? What is it? What are some factors of 54? Why am I mind blank right now? Oh yeah, 9 9 times 6. There we go. Okay, so 3 times 3, and then 6 is 3 times 2. So now we're pulling out groups of 3, aren't we? So we'll have now negative 15x. See why I'm saying negative 15x? Cube roots of 2x. And then it looks like 1, 2, 3, 4 x's. So we'll pull out an x. So then plus 7x cube roots of 2x. So now they are the same. So that would be negative 8 cube roots. No. Yeah, they are both cube roots. And they're both, I thought that was x cubed for a second, you know. So then I didn't think they were like terms. Do you see why I was thinking that? Okay, so negative 8x cube roots of 2x. So the apple part includes the x on this one, if you'll notice again. So let's pretend I would have had this. X squared. Could I have combined them? No, because then they aren't apples anymore. And they're not. Okay, awesome. I think we get the picture with that. So let's move on. I think we get the picture of something of that caliber. Now here's where something really interesting comes in that we've probably never seen before. It's not that we haven't seen it before. It's just almost like a trick question, this one. So if you look at it, this one simplifies, correct? 25 breaks down into 5 times 5. So then we would pull out a 5. So now we have this 5 square root of m. But now when you look at this one, do you see how it doesn't simplify? We can't pull out any groups of 4. This is almost a trick problem. Here's why. In this particular problem, if you think about it, this can be simplified in a sense, because what can that be rewritten as? Isn't that m to the fractional exponent? Roots goes on bottom, power goes on top. So that's actually m to the 1/2, right, everyone? So this is equivalent to this. So we actually do have minus 3, and then instead of that, we have the simplified version, the square root of m to the first. Well, now are they alike? Yeah, so they really are. So that's just one thing you have to check. So even if they're not the same, does it simplify to be the same by writing it as fractional exponents? So now we have 2 square roots of m. So look right here. Like at this one, we would simplify. So we'd have 5 root m. Now right here we would say, oh, it doesn't pull out, but let's check to see if it simplifies. So we have minus 3, and then that's m to the roots go on bottom, power goes on top. Does that simplify? No. So in this case, it truly could not be added together because it didn't simplify and it didn't come out to be like radicals. So that would be our answer.
And that's how you do that.
Yeah, this is just all we could do for this one. Okay, I think we're pretty good. So now this is the last little element here. With multiplication, this is like multiplying radicals here. So we know that we have this times all this stuff, right? So this times this would be 3 root 5, wouldn't it? Then this times this would be negative 4. And then look, you have a root 5 and a root 5, so that's root 5 times 5. You guys see why I'm doing 5 times 5? Don't we multiply what's under the radical together? So root 25. Then you would check, do any of my radicals simplify? This one, 5 times 5. So we pull it out and it's multiplication. So we have 3 root 5s minus 20. Now don't start doing weird things and saying, I'm going to combine 3 minus 20. They aren't even like, this is an apple, this is an orange. You can't put them together. That's our answer. You can only combine like radicals with like radicals. So we'd be done. So another one like that, we have cube root of 2 times 3, so that'd be 3 cube roots of 2. Then this times this, we'd have plus the cube root of 4 times 2, which is 8. Then you just check, do any of my radicals simplify? This one doesn't, but this one does, because we know that's 2 times 2 times 2, so we'll pull out a 2, and the radical's gone right there. So we have 3 cube roots of 2, and we have plus 2, which you can't combine those two things. Okay, now double distribution, guys. You have to be really careful with these. Honestly, these problems are easy, but they're also easy to miss by little errors. And it's stupid to miss little errors on a test because it's really easy stuff as long as you're careful. We have 2 terms times 2 terms. We're going to need to double distribute. So watch. 3 times 2 is 6. True? 3 times negative 3 root 7 is negative 9 root 7s. Now I'm going to cross out 3 because I've distributed it through to everything on the right. 2 root 7s times 2 is positive 4 root 7s. Right here's where usually people mess it up. Right here, this last one. 2 root 7s times negative 3 root 7s. You're going to multiply 2 to negative 3, which is negative 6, isn't it? Then you have a root 7 times a root 7. People usually mess up and just put root 7. It's not root 7. It's root 49. Then you'll just check, do any of my radicals simplify? Looks like this one does. It's 7 times 7, so that's actually minus 42, isn't it? Yeah, so 6 times 7, and we get negative 42. So now I'm going to go like this and cross that out, because we're actually dealing with minus 42. So then combine real parts with real parts. So 42, 41, 40, 39, 38, 37, 36. So that's negative 36. Combine whole numbers with whole numbers. And then these are like terms. So then we have minus 5 root 7. So the last one is usually where people mess up. That's just all I'm saying. It's not that it's hard. It's just easy to make an error. Okay, guys, remember that it's breaking the forbidden rule. If we have this, x minus 2 squared, it would not be appropriate to just square that, square that. That's not okay. Same thing here. Look, there's a plus sign. You can't just square that, square that. So we have to write this as 2 root 3 plus root 5 times 2 root 3 plus root 5. Isn't that what something squared means? Write it twice. And then we'll carefully distribute. So that would be 4 root 9. Careful here. Why did I get root 9? 2 times 2 is 4. Root 3 times root 3 is root 9. 2 root 3 times positive root 5 is positive 2 root 15. Cross that out. That times that is another plus 2 root 15. Then root 5 times root 5 is plus root 25. Break down any radicals that can be simplified. So isn't this 3? 4 times 3, everyone? Which is 12, and I'm going to cross it out. And then right here, plus 5 you're saying, so plus 5. So then we have 17. And then 2 plus 2 is 4. So plus 4 root 15. So really pretty basic stuff for today. That's really as hard as it's going to get. Okay, I won't do any more examples if you feel confident. So let's just look at our last examples. What would we write this as? Yep, that times itself. Good. We would double distribute, being really careful, right? And that is the end of the lesson for today. So the rest, you have a lot of time to work on homework. Yeah.